myclass.com.
Algorithm basics and data structures. What is an algorithm? Algorithm is a step-by-step procedure which defines a set of instructions to be executed in a certain order to get the desired output. Algorithms are generally created independent of underlying language. An algorithm can be implemented in more than one programming language. Basically, algorithms we can writing in our English language that is independent of any programming language. When we are going to the implementation phase, we can implement this algorithm in more than one programming language. So algorithm means it is a solution for a particular problem to get a desired output. Algorithm writing is a process and is executed after the problem domain is well defined. That is, we should know the problem domain for which we are designing a solution. Let's take an example. Making of a cup of tea. When we want to make a tea, it contains lots of steps, and also we can follow different styles for boiling the water by using kettle, by using gas stove, or by using traditional wooden stove, etc. So the choosing of that process will decide how much time it will take to make a tea. So that is the main step, is to get the idea of that problem, how we will get the solution of that problem. There are so many ways to make a tea. That means we will analyze, or that means we can create or we can write more than one algorithm for a particular solution. That here we have more than one process for making a tea. Clear? So that means the algorithm analysis is a very important topic. So what is algorithm analysis? Algorithm analysis deals with the execution or running time of various operations involved. The running time of an operation can be defined as the number of computer instructions executed per operation. In our example, the making of a tea. That means making of a cup of tea will take less time when compared to making tea for a particular function, making tea for a big family get together. That means the running time taken to make that tea is different when we are making it for a one person and more than one person. Is it? So the running time is the main part of algorithm analysis. So the algorithm complexity. Suppose X is an algorithm and N is the size of input data. The time and space used by the algorithm X are the two main factors which decide the efficiency of X, the algorithm. The time and space. Time to get that desired output, and also the space. Here the memory space that is used to implement that algorithm. So the time factor, time is measured by counting the number of key operations. Space factor, space is measured by counting the maximum memory space required by the algorithm. Let's go to space complexity. Space complexity of an algorithm represents the amount of memory space required by algorithm in its life cycle. So the space is composed of two components. One is a fixed part of memory space and the other one is the variable part. The fixed part is to store certain data and variables and also the constants. That is independent of the size of the problem. For example, simple variables and constant used, and also the program size. There is a small memory we are used to store the program itself, and also simple variables and the constant. That means here only we are using a fixed part of memory space. In variable part is a space required by variables whose size depends on the size of the problem. When we are going to add n numbers, in every execution we are entering the value of n. So in the first execution only two numbers. That means the variable, the size, the variable parts only for two variables. At that moment, we required only the memory space for 2 variables. But when we are adding 10 numbers, we have to store 10 variables. Is it? That means that is a dynamic memory allocation, recursion stack space, etc. So whose size depends on the size of the problem. Time complexity. Time complexity of an algorithm represents the amount of time required by the algorithm to run to completion. How much time is required? Time is the complexity of an algorithm. Time requirement can be defined as a numerical function T of n, where n can be measured as the number of steps provided each step consumes constant time. That n is, let's for example, addition of two n-bit integers takes n steps. Total time we can say that T of n equal to C into n. That means C is the time taken for the addition of 2 bits. So we have 10. Let's assume that we have 10-bit number, that for 2-bit number C millisecond time is required. So 10-bit number C into 10. So that is the value of T of n. So the T of n grows linearly as the input size increases. That is a very easy example for calculating time complexity. So this is all about algorithm analysis. Thank you.